Okay, mini review from yesterday. So I'll leave it up to you if you want to copy this down. It's in yesterday's notes. If you look at it, go, yep, okay, yep. That's a good sign. If you look at it and go, oh, what, huh? Then you probably want to copy it down, right? So, parabola. That's the shape of a quadratic, right? Parabolas can, in this course, we're just going to go open up or open down. Okay, and I got some nice graph paper here, so let me use it. That one opens up. Okay, this one opens down. Okay, so what else can we say about this thing? Parabolas, quadratics, they're all in the shape or the equation ax squared plus bx plus c. Okay? And because we have that square part, that's what makes it curvy. That's what makes it a parabola shape. What do we know about this thing? This thing opens up, then it has a minimum point. I'll just abbreviate it, minimum, okay? Does it have a maximum? No. It keeps going forever and ever and ever and ever and ever. That's what those arrowheads mean. Okay? No maximum. The opposite happens here. This doesn't really look like it's kind of centered on here, so let's maybe redraw that. Okay? And as we saw in our little graphing exercise, they're not always right centered along the y-axis. I could have one over here, right? I could have one over here. Okay? But for these examples, even that one looks pretty bad. Let me make my dot really big, okay? That has a maximum. No minimum. Keeps going down forever and ever and ever. Biggest number you can think of, negative, down on the y-axis, that graph will get there. Okay? What affects whether it opens up or opens down? Something in this formula, do this. What does that? What part is negative? See? The A, right? A. So this thing opens up if A is positive. Okay? So for an example, y is 3x squared minus 10x plus 2. I don't care about the minus 10x plus 2. Let's actually make that negative. The only part I care about if it opens up or down is, that's A. A is 3 here. That thing's going to open up. Okay? So you don't even have to put it in your graphing calculator. You know. If A is negative, then it opens down. Okay? So something like this, 4 plus 10x minus, let's go 0.5 x squared. A here is negative 0.5. A is, the word is coefficient, right? The coefficient of the x squared term, not just the first one, okay? That is negative, so it opens down. Okay, that's not the shape of this thing, of course. I'm just giving you some other example. Okay, so that was all yesterday. Now we're going to add some more stuff. Oh, what else about a parabola? What do I know about, let's do some fancy shading. What do I know about that side and that side? It's a mirror image. What's another word for that? Same. What's a word that means same in math? Lewis? Symmetrical.
Really? I said it like 3 times.
I heard same.
I said same.
Symmetrical? Reciprocal? We're not, don't worry, we're not. Reciprocal means like a fraction and you're flipping it. Yeah. Okay. Reciprocal. That has dual meaning in English. It means something else too. Let's not go there. Okay. So there's symmetry here. Okay. So something new. Vertex of a parabola. Okay, there's lots of different definitions. I'll say this one, but I won't write it down. It's where it stops going in one direction and starts going in the other direction. Okay, if I trace this down, you won't be able to see this on the recording. If I trace this down and go in the negative direction, right at this point, now I start going up in the positive direction. Okay, this guy, if I start going up, 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 right where it changes direction, and I start going down, 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 that's called the vertex. But let's use a different definition for it. This is the vertex. What is also this point called? Yeah, what is this point called, the vertex? The minimum. So let's write that. Where the max or the minimum point is. Okay? The book will probably say where it changes direction, where it stops going positive, starts going negative. Okay? Same thing. But visually, if we're looking on a graph, well, it's either where the max or the min is. It's either the top point or the bottom point. That's where the vertex is. Axis of symmetry. Okay? You guys know what an axis is. This is the x-axis. This is the y-axis. Guess where my axis of symmetry here is? Where is this mirror where the green side looks like the fuchsia side? It's the y-axis, isn't it? That's the axis of symmetry. Okay? So while the vertex is always a point xy, in both of these cases it's 0, 0. Okay, oh no, it's not in this case. Let's say that's 1, that's 2. This vertex is going to be 0, 2. Okay, vertex is always a coordinate. Axis of symmetry, it's always in the form, it's an equation. It's always x equals and guess what? Where your vertex is, that's always where your axis of symmetry is. So if you know the x coordinate of your vertex, then you know the equation of the axis of symmetry. Okay? Because it's at the same place. Does that make sense? Okay. Don't draw this, but as another example, all right, here's, you know, some other quadratic. There's an equation for this thing. There's some other parabola. Okay, what is the vertex here? Where's the maximum point? Okay, and let's assume we're just going to look at the big lines here. Okay, so that's -1, -2. This is 1 for y, right? This is always x. Okay, so my vertex is, what's the coordinates? -2 and 1. Okay, that's the coordinates of the maximum point. That's the vertex. That's when this thing starts coming up, starts going down, where it changes direction. What is my, and I'm going to abbreviate axis of symmetry because I just don't like to write that thing out every time. This is always in the form x equals, where is it? It's right here. That's where the left side looks like the right side. What is that line? Well, look at that point. That's what it is. Where x is -2. This is the line, x is -2. Remember that from linear inequalities? Anytime it's x equals something, it's always a vertical line. Okay? We don't have to worry about horizontal lines. Okay? Because the axis, our parabolas are always going to be opening up or opening down. Okay? We're not going to get one that looks like that. That's grade 12. Okay? So vertex, axis of symmetry. Example. Here's a graph. Now let me use that so you can see it better. Okay? Of course, I'm not being lazy. I'm not really doing this, but I hope we all understand our coordinate plane, our Cartesian coordinate is what it's called, right? Okay? Oh, I just moved that. All right, so what do I got? I got a point at 2, 3. 1, 2, 1, 2, 3. I have a point at 3 and 3. Okay, and my parabola looks like this. And we have some questions. A, max or min. B, vertex coordinates. C, hard to read with that pen. Equation of axis of symmetry. We got to find all this stuff, right? These are questions. D. Oh, I haven't talked about this yet. Domain and range. What's the domain and range of this guy? I'm going to remove that. That's it. A to D. That's it. I got green on green. That doesn't really, I didn't notice that until I looked here. It's almost the same color, isn't it? Here it looks a little shaded quite a bit differently. Okay, easy one. Does this have a max or a min? Definitely has a max. Vertex coordinates. Is that clear, cut, and dry, or do we kind of guess, or do you need to know something else to find out where the vertex is? Yeah, that's kind of like hanging up here in the middle of nowhere, isn't it? So we're going to tell you that if you have, if there are two equal y coordinate points, okay, the vertex is always halfway between them. Okay? Because this thing's symmetrical. There is some point where I have an axis of symmetry. Does it look like it's about there? Is that where the left side kind of looks like the right side? Yeah. What's the equation of that line? Well, look at this point. This is 2. Okay, let's use a different color. This point's 2. This point's 3. What's halfway between 2 and 3? 2.5. That will always happen, okay? So for here, if I go 2 plus 3, if I add my two coordinates and take the average of them, what's 5 over 2? 2.5. That will always work. Okay? Here you can see it's 2.5. But what happens if we get something a little more confusing? I can add this point, add that point, because here they have the same y coordinate. Okay? So my equation of the axis of symmetry, it's always in the form x equals, where's this vertex? 2.5. So my vertex coordinates are, where's this vertex? 2.5. Now for y, we don't know how to do this yet. I'll show you soon, but today we're just going to guess. That looks like about what? Approximately 3.5. Okay, for today that's fine. All right? On your calculator there's a way to find the maximum point, but I'm not going to show you that yet. Okay? But this point, remember this. Okay? Now, domain and range. Who remembers what that is? Yep. Megan, what's domain mean? Anybody agree? Yeah. That you have to memorize. Domain is the x values of the graph. And then you have to look at your graph. What possible x values are part of this domain? What are the x values of this graph? Well, what does this arrowhead mean again? Ever and ever and ever. So we don't even have an equation of this thing, but could I put x as 5 in this thing? Could I put x as 100? Could I put x as 1 billion? Is there any restrictions on how far out this arrowhead's ever going to go? No. Positive infinity for x. How about in that direction, in the negative x direction? Okay? There's no restrictions. This goes out and down forever and ever and ever. Remember I said it never curves back in. It just keeps getting wider and wider and wider. All the way out to negative infinity. All the way out to positive infinity. What's a way of saying all x's you could possibly think of and then some? Okay? Domain, x, Greek letter E called epsilon, real numbers. All the decimals, all the fractions, everything, everything, everything. Okay? There's no restrictions for x. And, of course, all these values too. Okay? X goes from positive infinity all the way to negative infinity. Okay? This arrow keeps going out forever and ever and ever. So if I picked some number way out here, negative 1 billion, okay, and 12, eventually that arrowhead will get out there. Okay? Range, domain's x values, range is the y values. You have to memorize that, right? Most of us have it from grade 10, but hey, maybe we lost it. Maybe we never got it. I don't know. Okay? What are the y values of this graph? From this point down, is there any y value this arrowhead won't get to? No. Okay? Negative infinity, it goes down to. I know this is getting pretty messy, but I am restricted how far up it gets, right? This thing has a maximum. You need to know the maximum of that point. Here we guessed that was about 3.5. Okay? So it's, in English, every y value less than or equal to 3.5. But how do we write that in math? Everything less than or equal to 3.5, where y is real numbers. Okay? We just finished inequalities, right? That should make sense. Any questions on that? Okay? And we're dealing with parabolas. Okay? You know what? I bet you on every question the domain will be that. If we've got arrowheads there, they're either going to go up, they're going to go down. Okay? That's probably going to be your domain. I already talked about that. No, we're not doing sideways ones. Ah, you remember that part. Okay? So, a few more terminology stuff. Domain, range, vertex, axis of symmetry. Let's look at one more example. And you're on your own. Okay. There's a little graph. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. 6, 4. There's a point. 7, 8, 9, 10, 11. There's a point. And my graph looks like that. I can't see my points anymore. Let me emphasize. Do you think that could be a real-life object that someone threw? Maybe it's an arrow someone shot. Maybe it's a golf ball someone hit. There's an equation for that. You notice I'm just using the first quadrant, the positive one. I don't really care about the negative one over here. I don't really care about the third quadrant down here, negative, negative. I don't care about this one. This is just positive. Anything you throw up, you know it's going to come back down to Earth, right? Gravity does that. Maybe if you threw it hard enough, it would escape the atmosphere. Okay? Well, that defies gravity because it's less dense than the atmosphere. So it rises till it gets to a certain point, and then it explodes because there's not enough pressure holding it together. Yeah. Hopefully it doesn't go through an airplane. Okay. Does this open up or down? It opens down. I'm not even going to write that. Whoop. Hey. Okay, what's the domain and range? B. What's the vertex? C. What's the axis of symmetry? All right, well, let's go domain and range first. Do we have arrowheads here? Okay, so for this question, is there any x value, positive infinity, that this thing won't get to? It's going to keep going. How about down to negative infinity? For domain, x is all real numbers. Now I did say this could be something we threw up. In real life, is it going to go on forever and ever and ever, or is it going to stop when it hits the ground? Okay, yeah. So keep that in mind. We're not there yet, but in real life, yeah, it doesn't go to positive infinity. It'll stop right there. That would be the x values from where I threw it to where it landed. Okay, but today we're just going to write that. Range. Well, range is everything from here down. What is that point? Well, where that point is, that's about here. That's the vertex, isn't it? Where the vertex is, that's also the axis of symmetry. So, what's my vertex? Again, I don't know where this point is. How do I figure it out? Is this an equal y point here for both sides of the parabola? Yes. So I know that is my axis of symmetry. That's where the left side looks like the right side. How do I find out the equation of that line? Because it's kind of hard to see here. Do I have 2 points with equal y coordinate? Then you take the average of those points. 6 and 11 divided by 2 is 17 over 2. That's 8.5. That's the x-coordinate of the vertex, and that's also the equation for the axis of symmetry. Okay? So just like the last question, well, there is a way to get the maximum point. Okay? We're not quite there yet. That kind of looks, let's just estimate it at about 4.5. Okay? Four and 3/8. Okay, fine. All right, so we need that to get the range. So the range again is every point from here down. That's the y values for this graph, forever and ever and ever, right? Okay, so all the y values less than or equal to 4 and 9/16. Okay, and then to be specific, this isn't integers, this isn't just the dots, this is everything, all the fractions, so we should say where y is the sum of all real. Okay? So, vertex, axis of symmetry, domain and range. 4 new terms. Page 368, number 1 and 3 to 6.